Oh, hold on. What's that? Ladies and gentlemen, the hall sensor is damaged, and I believe we found our culprit. It makes sense now. Hello, and welcome to my workshop. Today we have a Lenovo IdeaPad 3 for repairs. The problem with this one is the screen backlight flickers when you turn it on. With a fault like this one, there are a few voltages that I will be interested in. The first, LED_VCC. This is high voltage coming directly from the adapter or battery. This is a power supply for the LED backlight of the screen. On this very laptop, it will be 20 volts if the system is running on adapter, or 8 to 10 volts if the system is running on battery. The second is LCD_VDD. This is a 3.3 volts power supply for the LCD itself. Don't be confused. LED is just a backlight, and LCD is the screen itself where the image is displayed. Two separate things. Number 3, we have LED_PWM and LED_EN or enable. Both are 3.3 volt signal lines. I need to check if all these voltages are present. So let's disassemble the laptop. Always make sure you use the proper screwdriver and a prying tool for disassembling laptops.
It looks something like this.
Disconnect the main battery. This job should be done with battery disconnected. I'll remove the screen bezel and start measuring voltages. Be careful not to break the bezel or damage the screen. As you can see, we have LED VCC, which is around 20 volts. At this point, I forgot to record the multimeter readings on video, but all the voltages were normal except LED enable, which was reading around 1.8 volts, which is not normal. Just watch. If I short LED PWM and LED enable, the flickering stops. The backlight is stable. You can see it right there. So what I will do next is to use a jumper wire to bridge the two test points and see what happens. I'll apply some flux and some leaded solder. Let's introduce our jumper wire. Flax is always good. You can use a lot of flax.
It looks something like this.
A little bit of cleanup, 70 or 100% alcohol is good. Time to test. Well, it's stable from the beginning, but the flickering starts again. This solution didn't work this time around. Let me take out the motherboard and inspect it under the microscope. Be careful not to damage any cable. Let's inspect it under the microscope now. It looks fine. Yeah, this looks okay. These sides are good. It's okay. A little bit of corrosion over here, but it's fine. Oh, hold on. What's that? Ladies and gentlemen, the Hall sensor is damaged, and I believe we found our culprit. It makes sense now. It's all corroded. Wow. Wow. So what's a Hall sensor? The Hall sensor is the reason why when you close your laptop whilst it's running, your laptop goes to sleep. And how does it work? It's a 3-terminal chip and activated by magnets. Pin 1 is VCC, which is 3.3 volts, which comes from one of the laptop's power supplies. Pin 2 is ground, which is 0 volts. Pin 3 is Vout, also 3.3 volts, which connects to the embedded controller or EC chip of your laptop. When you close the laptop whilst it's running, a small magnet inside the screen assembly will activate the Hall sensor. The sensor then pulls the Vout pin, which connects to the EC, to ground, which turns it to 0 volts. The EC sees 0 volts on the pin and puts your system to sleep. Simple, but clever. Let's replace it and see what happens. (350°) hot air will do it. Yeah, that place is a little corroded. I think it will work. Let's bring the new Hall sensor and install it. Don't forget flax. Flax is always good. And our leaded soda. Always use leaded soda. It's our new hall sensor. So let's install it. (350°). Hot air is fine. A little cleanup. Let's connect the screen back. Okay, moment of truth. Success, ladies and gentlemen. The laptop is fixed. Fantastic. Fantastic. Wow. Well, I hope you learned something.